Alright, so continuing on with the mathematics review, this is mathematics review video number 2. Unit conversions. All APES students should be able to convert from one system of units to another. Well, you never have to memorize these kinds of conversions. They will always provide for you these kinds of numbers here. What you do need to memorize are really these kinds of metric conversions. That's it. Or, as I told you in the last video, this stuff here. But if they ask you to convert like from tons to kilograms or BTUs to calories, they will always provide you with the conversions, so there's no need to memorize these kinds of conversions. So let's go ahead and do number 14. A city that uses 10 billion BTUs of energy each month is using how many kilowatt hours of energy? Now the numbers here are ugly, so you can go ahead and use a calculator for this one. So we have here 10 times 10 to the 9th, because it says 10 billion, and 10 to the 9th is billion. That's BTU. And it gives you a conversion. It wants how many kilowatt hours of energy, and it tells us here that a kilowatt hour is equal to 34,113 BTU. So because we have an equal sign, I can put these numbers on either side of the line here, depending on what I need them. Well, I need BTUs on the bottom. So 34,113 is on the bottom because I want to cancel these out. And then I can just put kilowatt hour at the top here. So again, when you have an equal sign, you can use either number on either side of the line. So when you use a calculator to divide this out, because again it is really ugly math, you end up with 0.0003 times 10 to the 9th, which in proper scientific notation is 3 times 10 to the 5th. And this is the correct answer. 58,000 kilograms of solid waste is equivalent to how many metric tons? Well, it tells you here that a metric ton is 1,000 kilograms. So I want kilograms at the bottom. So 1,000 kilograms, and then metric ton is at the top. So I'm just taking 58,000 divided by kilograms. My kilograms cancel out, and my answer here is 58 metric tons. Turning over to number 16. A barrel of oil is equivalent to 42 gallons of oil, or 159 liters of oil. And again, use a calculator for this because the numbers are ugly. On the AP test, they may ask you something like this, but the numbers will be prettier and easier to do by hand. So for letter A, we're going to take 6 million BTUs, because it says so here. If 1 barrel of crude oil provides 6 million BTUs of energy, so 6 million is 6 times 10 to the 6 BTU, and that's per barrel. And it's asking us how many BTUs of energy will 1 liter of crude oil provide. It says a barrel of oil is equal to 159 liters. So 1 barrel is equal to 159 liters. So now my barrels cross out. 6 million divided by 159. Again, use a calculator because it's ugly. 37,736 BTUs per liter. And that's your answer for A. B. How many calories of energy will 1 gallon of crude oil provide? For this one, you needed to flip back to number 15. And so if we flip back to number 15, it's going to give us calories right here. 34,113 BTUs is equal to 60,421 calories. So the first thing we have to do is again start with 6 million BTUs per barrel. And this time we want gallons instead of liters, so 1 barrel is equal to 42 gallons. So now my barrels cross out and I have 142,857 BTUs per gallon. But I'm not done. So I'm going to take this answer and I'm going to multiply this by that horrible equation from chapter 15 or question 15, which says that there's 860,421 calories per 34,113 BTUs of energy. So now my BTUs cross out and I have calories per gallon, which is what my question asks for. How many calories of energy per gallon? So doing with this a calculator, because again it's terrible, we have 3,603,235 calories per gallon. That is our answer. This is about as hard as you're going to see on the AP test. This question, A is more like what you'll see, and A is pretty straightforward. B, on rare occasions, they'll have something as hard as B. Again, once every few years, they'll have something this hard. Usually one small part, 1 point of an FRQ out of 11. So again, if you don't get B right, don't panic. If you don't know how to do B, it's okay. That's about as hard as you get, and you probably won't see something this hard. But A, again, is more like what you would see. For crude oil, if 150 pounds of CO2 is released per million BTUs of energy, how much CO2 is produced by each barrel of crude oil? So we're going to take 150 pounds of CO2 per million BTU. And it's telling us that there's 6 million BTUs, 6 million per barrel. And that's BTU per barrel. So now my million BTUs cancel out, and so it's really just 150 times 6, and that's going to give me 900 pounds CO2 per barrel. Oh, I'm off the screen, excuse me. 900 pounds CO2 per barrel. All right, percentages. A natural gas power plant is 60% efficient. If 1 cubic meter of natural gas provides 1,000 BTUs of electricity, how many BTUs of waste heat were produced? This is the product here. What came out of the plant was 1,000 BTUs of electricity. So what we're looking for was the original amount of BTUs that went in if 60% of something is equal to 1,000. Product here. This is our product of power plant. So let me start over here. What we need to do is just sort of write this out. 60% of some number, so I'm just going to call that number X, is equal to 1,000 BTUs. And so let's not use the percentage here, so it's 0.6x is equal to 1,000. And this is just basic algebra here. And my result is 1,667. So 1,000 divided by 0.6 gives me this number. Well, this is the number I started with, and this is what I got in electricity. So how much was waste heat? Well, so you have 1667 minus 1,000, so we're going to end up with 667 BTUs of waste. Here. If 35% of a natural area is to be developed, leaving 500 acres untouched, how many acres are to be developed? So 35 is the developed area, 50 is the untouched. Well, if 35 is developed, and it has to equal 100%, so 100% minus 35% gives me 65% that's untouched. So again, 35 is developed, 65 is untouched, and that's just because it has to equal 100%. So 65% is untouched. So 65% of what? Of some acreage is equal to 500 acres. So it's 0.65x is equal to 500. Let's just go ahead and do my algebra here, and I end up with 769 acres. Now, this is untouched. The question is, how many acres are to be developed? I'm sorry, the 500 is untouched, so the x is the total amount of land. So if 769 is our total land, and 500 is untouched, what's developed? Well, it's just 769 minus 500 gives us 269 acres that are developed.